what we will be doing is that we will try to complete some part of the Boolean algebra. Okay, and in this Boolean algebra we will going to see first that why we are requiring this Boolean algebra. So as we all know that we are learning the digital electronics, and whenever we are using a digital electronics, what we are doing, we are solving the expression, whatever the expression we have got, whatever the logic circuit we have got, we have to solve that. Let's take an example of a calculator. If we are doing the addition, we have to add two numbers or more than two numbers. If we have to subtract number, we have to do the subtraction, we have to do the multiplication, we have to do the division. Sometimes we have to find, instead of this addition, multiplication, subtraction, we have to perform some of the expression like log x, tan x. These are also the some of the arithmetic operation. Apart from this, we sometimes what we require, we have to solve the logic conditions. Okay, logic condition means, let's say if we are talking about the switch, so we can say that switch, we are opening and closing the switch. So switch can be on and off, so it can be a logical condition. So basically what we can say is that we required a logic or logical, you can say logical simplification expression. Okay, so what we can do in this logical simplification expression, we can use some of the method. So one of the method that is being used in this is known as the Boolean algebra. So what the Boolean algebra will going to do, that whenever we are talking with respect to the 0 and 1, we will be talking about the Boolean algebra. That means now we will talk about the number of variables also. So we can use this Boolean algebra for the number of variables 1, 2, and I can say 3. So we can use this variable 1, variable 2, or variable 3. Means if I have a number, so I can represent it in the form of A, B, and C. So I can use a 3 variable. If I have a single variable, I will be using A. If I have a 2 variable, I can use it as a and B. If I have a 3 variable, I can use it A, B, C. So whenever we are talking about the Boolean algebra, what we are doing, we are solving the problem when we have got 0 and 1. Apart from Boolean algebra, we have got another thing which is known as the K-map. So in this, what we are doing, apart from this 0 and 1, we have got one more thing that come into the picture, which is known as the don't care. Okay, so we are using a cross symbol that is being used as a don't care. So when we will go into the K-map, we will going to explain what is this role of this don't care. For solving this K-map, we require a variables. We can use only a variable 2, 3, 4, 5. Okay, so we can use a variable, 2 variable, 3 variable, 4 variable, and 5 variables K-map. And this is the limitation. So Boolean algebra has got a limitation that we can use only a variable till 3, 1 variable, 2 variable, 3 variable. K-map, we cannot use 1 variable. That means we cannot draw a K-map for a single variable. We always require a 2 variable to draw a K-map. So we will start with the 2 variable K-map, 3 variable K-map, 4 variable K-map, and 5 variable K-map. So K-map has got the limitation of this. After this, what we have got another method which is known as the tabulation method. So this tabulation method is being used. Again, we will be using this 0 and 1, 0, 1, and cross. But the advantage of this tabulation method is that we can use it for any variable. Let me write any number of variables. So we can use it for any number of variables. We can use a tabulation method for 2 variable, 3 variable, 4 variable, 5 variable, 6 variable, 7 variable, 8 variable, whatever the variable you want to choose. So these are the some of the logic simplification expression that is being used in the digital electronics. Got it? We have got Boolean algebra, we have got K-map, we have got a tabulation method. So coming to the Boolean algebra, so we will be picking this Boolean algebra right now. So you know that Boolean algebra, we can use only 0 and 1. So we will be using this 0 and 1 first to solve the logical expression. So with the help of this logical expression, we will be solving some of the relations that is available in the digital electronics. So we will be talking about here about the Boolean algebra. So I will be writing a short form. Whenever we are solving this 0 and 1, we can either do the addition or we can do the multiplication. Because you have already seen that when we are doing the subtraction, that subtraction can be done with the help of a addition. If you are performing a minus b, that a minus b can be done with the help of a addition only. The thing you have to do is that you have to complement it. So what we can say that whenever we are talking about the Boolean algebra, so we can have two type of things. One is known as the addition and we can say another is the multiplication. Whenever we are talking about this addition, we are saying that we are performing some of the operation related to the OR. And when we are talking about the dot operation, we are saying something is been related to the AND. So we have got a Boolean expression which will be solved with this plus and dot operation. So let's take an example. Suppose if I have to perform an AND operation. Again, I'm not saying AND gate. I'm not saying OR gate. I'm not saying AND gate. Okay, I'm only saying OR operation and the AND operation. OR means addition and AND means multiplication. Okay, we are not talking about the gate. So let's say if I talk about the AND operation. So let's say I have a two variable. So I can have a combination like this. Let me draw a table like this. So I can have a operation like this. I can have a 0. If I talk with respect to 0 and 1, so I can have an operation like this 0 dot 0. Okay, I can have an operation like this 0 dot 0, 0 dot 1, 1 dot 0 and 1 dot. This is clear. So 0 dot 0, 0 multiplied by 0 will give you what? 0. 0 multiplied by 1 will give you 0. 1 multiplied by 0 will give you 0. 1 multiplied by 1 give you 1. So what answer we will be getting? We will be getting answer here 0, 0, 0, 1. Now 0, 0, 1. Yes. Now what we will do? We will perform an AND operation. So let's say if we want to perform an AND operation with the help of a variable. So right now we have taken 0 and 1. So what I will do? I will replace this 0 and 1 with the help of their variable. So I will be taking one variable. So I will be performing AND operation. So let me do the partitioning of this page here. So I will be performing this AND operation here. So what I can do? Okay, so let's say I have a I can have a value a. So I can have a dot 0. This can be one my combination. I can have a dot 1. This can be one combination. I can have what other combination I can have? I can have a dot a. That means two variable. If I have selected a variable a, I can multiply that variable by itself, or I can have a variable a dot a bar. So these are the four combinations a into a bar. So first thing, a multiplied by 0. What will be the answer? 0. A multiplied by 1 will be your a multiplied by 1 a, because we have got 1 and something we are multiplying with any of the variable, that we will be getting that answer. Okay, so a multiplied by 1 will going to give you a. Now a multiplied by a, what will be this? Okay, so a multiplied by a, that means you are multiplying a variable a with the same variable a. So you will have you will not get a square, because we don't, in digital we are not talking about the square. What we will get? We will get a same variable. A multiplied by a will going to give you your a. So you will be getting a. And if I ask you what will be the a multiplied by a variable, a multiplied by a variable will be your 0. Okay, why? Because if I suppose my a is 1, my a bar will be equal to 0. So 1 multiplied by 0 will going to give you 0. So a into a bar will be your 0. Now similarly we will go for the OR operation. We will go for OR and then we will go for the OR operation. So whenever we are writing OR, what we can do? We can write it in the form of 0 plus 0. I will copy this only. 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. So what will be my answer? 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So I will be getting the answer 0, 1, 1, 1. Similarly, when we are talking with respect to the OR operation, so this will be the important. If I am talking with respect to the OR operation, we have an answer like this: a plus a. I can have an operation like a plus a. I can have a plus 0. I can have a plus 1, and then I can have a plus a bar. Now this is important. What will be the a plus a? A plus a will be your a. Yes, a plus a will be a, because a plus a will be your 2a, and we don't have a 2. We are not solving that 2. We will going to save it as a. So a plus a will be your a. Okay, what will be a plus 0? A plus 0 will be your a, because again 0 do not have, we are not talking about the 0, because 0 does not have. Whenever we are adding some variable with a plus 0, it will be your a. So we will got to have a. Okay, now this is important. What is a plus 1? A plus 1 is 1. Why it is 1? Now my question is why it is 1. So let's say if we have got this a equal to, because a is a what? A is a variable. If value of a is 0, 0 plus 1 will going to give you 1. If a is 1, 1 plus 1 will going to give you 1. Okay, so a can have any value, but when we are adding it with 1, so the result will always going to become a 1. Okay, is it clear? So a plus 1 will going to have you 1. Okay, now again, what is a plus a bar? Again you can see, if I am taking a, if my a is equal to 0, so my a bar will be equal to 1. So it will going to become always 0 plus 1 or either 1 plus 0. So it will going to always result into a 1. So a plus a bar will going to result into the your 1. So it will going to result into the 1. So this operation is clear to you. If this operation is clear to you, your Boolean algebra is clear. Solve some of the basic questions. Let's say, let's take an example: a plus ab bar. So if I want to solve this, what will be my answer? We can take a common from this, and we can write 1 plus b bar. What 1 plus b bar will going to become? It will going to become 1. Okay, so it will going to become 1. So what we are doing, we are multiplying a dot 1. So what will be a dot 1? This will be equal to, let me take another example. Let's say I have got ab plus ab bar. Ab plus ab bar. So what will be the answer? Just do it and tell me the answer. Again we have to follow the same logic, that we have to take a common a and b plus b bar. So what is b plus b bar? B plus b bar is your 1. This will be equal to 1, and this is a equal to 1. So again you will be getting a. Now let's say y equal to, let's say y equal to, I'm giving a question, ab plus a bar b plus ab bar. So if I ask you, what will be the answer? Yes, please tell me the answer for this. See, again follow the same rule which I have told you. Follow it and then you will be able to solve it. If I take this one, in this, if I consider this 2, so what is common in this? So I got that b is common. If I take second term and the third term, is there any common? No. So that means we cannot take anything common from this. If I consider first and third, is there any common? A. इन तीनों एक्सप्रेशन में से कौन सा टर्म ऐसा था जो दोनों के साथ कॉमन था? वी हैव गॉट 3 टर्म्स, ए बी, ए बार बी एंड ए बी बार. सो व्हाट आई कैन सी, कि हम यहाँ से ये देख सकते हैं कि हमारे जो एक टर्म ए बी है, दिस ए बी कैन बी कॉमन विद बोथ टर्म. फर्स्ट टर्म कैन बी कॉमन विद बोथ. First term can be common with both. We know the rule that if I add a plus a plus a, this will be your a only. Similarly, if I add ab plus ab, this will be always equal to ab. Okay, is it clear? If I add a plus a, that will be a. If I add ab plus ab, it will be always ab. So can I write a question in such a way that I can write y equal to ab plus a bar b plus ab bar plus ab. So if I take this common from here, so my answer will be b plus a into a bar And from here, what I can take common? I can take a common. So my b plus b bar. So what is a plus a bar? This will be equal to 1. 1. This will be equal to 1. So you will be getting b multiplied by 1, a multiplied by 1. So answer will be a plus b. Y equal to a b bar plus a bar b bar, a bar b bar plus a bar b. You have to solve this. Okay, so I have told you the trick. Okay, first find out which term will be common. A b bar plus a bar b plus a bar b plus a bar b bar, because what we have seen that in this what was common, in this b bar was common, and from this what was common, a bar was common. Okay, so you can see that which term is coming out to be common. This is a shortcut method. You can find out that this a bar and b bar is common. So you have to add this a bar b bar. Even also if you see which one was common, a and b. So simply you have to add ab. So got the shortcut method. So in this I can take a plus a bar into b bar plus a bar common, I can say b plus b bar. Okay, so a into a bar will be equal to your, what will be the answer? Your answer will be a bar plus b bar. So you got this trick. We have talked about this a b bar. What was the variable? Number of variable in this? 2. Okay, number of variable were 2. Now we will going to increase the variable. Okay, so let me go with the 3 variables. So let's say if I going to take a, b and c. So let's say I take a plus b and let's say another a plus c. Multiply form we have seen in the, that means in the AND operation we have seen. So in the, if we are following the OR operation, this can be one of the combination. So we have to simply follow the multiplication rule, that this a will going to multiply by this a first, and then this a will going to multiply by this c, and similarly this b will going to be multiplied by this, and this c will going to be multiplied by, sorry, b will going to be multiplied by this c. Let's say this is my y equal to a into a plus ac plus ba plus bc. Here a is common, here a is common, here is a is common. So can I take this out of this a common, and what will be this a dot a? A dot a will be a plus ac plus ba plus bc. Okay, if I take a common, so 1 plus c plus b plus bc. Can I write like this? And what will be this? 1 plus c plus b. Anything in which one we are adding 1, it will going to become 1. So this will going to become your 1. So you will be getting a plus bc. So this method is clear to you, a plus bc. We can also solve this with the help of a shortcut method also. Okay, so let me share a shortcut method also with you. So what the shortcut method say, that if you have an expression like this, y equal to a plus b and a plus c. So if you have a variable, first variable, if these both variable are same, so what you will going to do, you will going to multiply the first value with the first value of the another variable. Means you will going to multiply this with this and this with this. When this value a, जो ये a है यहाँ पर और यहाँ पे, if it is common, you have to do this only. That means you have to get the result like this: a multiplied by a plus b multiplied by c. So it will going to give you a plus bc. So you can just check it, this example with here. Take an example and check if this is working or not. So let's say my y is equal to x plus y into x plus z bar. From shortcut trick, just find what will be the answer using this shortcut tricks. So according to my shortcut tricks, my answer should be x plus y z bar, and just check it whether you are getting this here or not. So I can say I have to multiply x dot x plus x into z bar plus y into x plus y into z bar. Again, x is common here. I will going to take x 1 plus z bar plus y plus yz bar. Okay, so this will going to become 1. So you will get x plus yz bar. You are getting this? So this theorem which I have shown you, this is one of the theorem which is known as the transposition theorem. So this is known as the transposition theorem. So let's take an example: a plus b plus c bar, or c, a plus b plus c. Let me take a simple one, and let's say a plus b plus d. Now do the solution and find out what will be the answer. So now you can see, if I follow the shortcut method, okay, so you can see that which one is common. These two are common. Okay, so I can multiply this 2 and I can multiply this 2. So my answer should be something like this: a plus b plus cd. My answer should come like this: a plus b plus cd. But you can just check it whether you are getting it or not. So what you have to do, you will find that when I will going to write this expression, it will be very huge expression. A into a, ab, ad plus ba plus bb plus bd plus ca plus cb plus cd. You can see this expression. Okay, then what we can write? We can write it as a plus ab plus ad plus ab plus bb plus bd. Sorry, bb can be written as b only. This bd plus ac plus bc. Let's say cb, I am writing bc plus cd. Now again you can see that in this, where a is common, I am writing the a common word. A here common, 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 common. So can I write this like this? A 1 plus b plus d plus this ab plus ab again can become 1, but I am writing here only b plus c. Okay. Now take where b is common. B is common here because I have already taken this one. So b is common here, b is common here, b is common here. Okay, so I can write b 1 plus d plus c, and what is remaining last? Your cd plus cd. Now you can see your answer will be a plus b plus cd. Okay, so I have just told you that what are the various way of solving it. So basically, when we are talking about this term, why I have shown you these two terms, okay, that is ab, that is a multiplied by b, and a plus b, because this is known as sum of the thing which is known as the product of sum or the sum of product.
In next lecture, we will going to discuss about the SOP and POS forms of a Boolean algebra.